Hey, it's Mr. Allred. I'm going to work some problems here, some odd problems from the book so that you can check yourself and maybe if you have questions, kind of help you figure them out. Page 174, number 1, y equals x to the fifth minus 0.125x squared plus 0.25x. All three of those parts are the power rule. So the derivative will be, on the first one, x to the fifth will be 5x to the fourth. The 0.125x squared, that will be negative 0.25x. And then the last one, 0.25x, will be just 0.25. And if you need some details on that, just let me know. But I just used the power rule on all those. Number 3, y equals x cubed minus 3 times the quantity of x squared plus pi squared. The first thing I would do here really is I would distribute that negative 3. So I'd get rid of those parentheses because they're not doing anything except holding you up. So x cubed minus 3x squared minus 3 pi squared. So let's use the power rule on these because that's what we have for the most part. X cubed, when you take the derivative, would be 3x squared. Negative 3x squared, derivative would be negative 6x. And the thing that can throw you off here, if you're not familiar with it, will be the negative 3 pi squared. Well, pi is a number, 3.14. So this whole thing that I've highlighted, negative 3 pi squared, is just a constant. So that goes to 0. Now, we definitely wouldn't put in our final answer, but if you're trying to figure out where it goes, the derivative of any constant is 0. So it just goes away. I wouldn't write that 0, but I just wanted to make sure you know what happens to it. So pay attention. Our variable there is x, and pi is a number. Okay. Moving right along here. The next odd problem, what was that? Is number 5. It's y equals the quantity of x plus 1 squared times the quantity of x squared plus 2x. You have the option of multiplying all this out if it helps, but I'm going to use the product rule instead. So I'm going to use the product rule. And in the product rule, I'm going to let u be the x plus 1 squared and the v be the x squared plus 2x. Okay. So when I go to do the derivative of u over here, I see those parentheses. With a power, it's a power rule, but it's a power rule that contains a chain rule. Now, it won't look like a whole lot, but as far as the chain rule goes, the x plus 1 is the u. So the derivative I'm going to write is 2 times whatever u was, and then it'll be times the derivative of u. And going back, remember that our u was x plus 1, and derivative of x plus 1 would just be 1. So my exponent went down to 1, so I wouldn't write it. Now, normally I don't usually clean this up, but I can distribute things out there, and 2 times 1 is 2, but u prime would be 2x plus 2. Over here with the v, I don't need a chain rule. So x squared just goes to 2x, and 2x goes to 2. So both of those derivatives turn out to be the same thing, even though they are not the same function to start with. So in putting this back together, we're doing the product rule. So the way I give it to you is v, which is x squared plus 2x, times u prime, which is 2x plus 2. So let's label that. So what we have here, this is v and u prime, plus the rest of the product rule, which would be u, which is x plus 1 quantity squared, and times v prime, which is 2x plus 2. So that is u and v prime. And the book kind of does some stuff to clean that up, but if you go through this version, you have the right answer. I'll go back and make a little note here where I've underlined in blue. That was the chain rule. Okay. So I used a product rule, a chain rule, and a power rule there. Okay. Number 7. Y equals the quantity of theta squared plus secant theta plus 1 all cubed. Okay. So the thing that's happening here is a great big chain rule. Well, excuse me, a great big power rule, but with the theta squared plus secant plus 1 being the u. So if that's the case, let's go ahead and write out what we've got. We've got y prime will be 3 from the power rule times something squared. Okay, and that something inside will be u. I hope I left enough room. And on the outside we will have the derivative of u, and we may or may not clean up depending on how it looks. Okay, so let's see here. The part that goes inside the u is the original, theta squared plus secant theta plus 1. And then the outside part, the derivative of that, derivative of theta squared will be 2 theta. Derivative of secant is secant theta tangent theta, and the derivative of 1 is 0. I'm not going to write it. So let me extend that a little bit further here. Try and outline that pretty good. You could distribute that 3 if you like. I don't see any point in doing anything else to this unless you just really want to. So let's see here. Let's go ahead and do number 9 since I can see it. Haven't written it down. I got plenty of time for this video. So number 9, since I'm doing the odd ones for you, is S equals the fraction square root of t over 1 plus square root of t. Now you can look at this and tell it's going to be a quotient rule, so I'm going to go ahead and label my u and my v. So I'm doing a quotient rule because I see the fraction. The u will be the top, the square root of t, but I'm going to go ahead and rewrite that as t to the 1/2. And the v will be the denominator 1 plus square root of t, but I will write it as 1 plus t to the 1/2. So once I have those two things identified, the derivative of t to the 1/2 will be 1/2 t to the negative 1/2, and the derivative of 1 is 0, and again the derivative of t to the 1/2 is 1/2 t to the negative 1/2. So I've got all the parts of the quotient rule. So let's go ahead and put it back together. So, not y, I was getting ready to write y. So S prime, just going to create a big old fraction. So up top I have v, 1 plus the square root of t, or I'm going to do this t to the 1/2, times the derivative of u, 1/2 t to the negative 1/2, minus u, which is t to the 1/2, times the derivative of v, which is 1/2 t to the negative 1/2, and that's all going to be over the original v squared, 1 plus t to the 1/2, all that squared. So just to make sure you see where everything came from, here is v u prime minus u v prime all over v squared. I don't know that I would really want to clean that up personally. If I had a reason to, I might, but I'm just going to leave it there so you can see what you would go through. Now, if you got some questions and the back of the book looks a little bit different, let me know and I'll be happy to kind of walk you through getting to the back of the book.